Hello again, Twitch, or should I say howdy? It's Howdy Partner. It's Howdy Partner again. We've got Claudine back. She came back.
I can't believe you guys allowed me to do that.
Well, I thought you were not gonna show up after coming on Twitch for the first time.
No, it was fun last week, so
Okay.
there you go.
Okay, good. I was worried that you didn't have fun. You were amazing, and I, will bend over backwards to get you back every time. But we've also got a new friend over here. Over there.
Over here for me.
Yeah. It's our friend Kirk. Kirk is from Datadog, and Datadog is our partner today for Howdy Partner. Claudine, do you want to give us a rundown? What is Howdy Partner?
So I'm gonna request you first to do like a little yeehaw, because I feel like that would be the appropriate way to start this whole thing.
Wait. Mo gives us three choices, and it's usually how to end it. We forgot to do this, by the way, of our last stream. We didn't end it the way we're supposed to. Mo, I think, was very disappointed. We get three choices just as a preview for you, Kirk, to end the stream.
Okay.
You can think about this the whole time. You can choose yeehaw, giddy up, or y'all come back now, you hear?
All right. Okay. I definitely have a preference in mind.
Okay. So I'm supposed to kick it off though with a yeehaw. Is that right, Claudine?
Yeah, totally. That was amazing.
Oh, that one counts? Okay, good. Perfect. I'm A.M. Gravelning. I'm one of your hosts here from AWS. I'm a solution architect at AWS. I work in the partners organization with wonderful people like Kirk over there, who is from Datadog. Datadog is one of our AWS APN partners, right? Or Amazon Partner Network. I'm joined down that way by Claudine. Claudine is also a partner, solutions architect. Tell us about yourself, Claudine.
Yeah, so I've been in role for almost 3 years now. I was just telling Kirk here that I'm celebrating my 3rd-year anniversary at AWS this week, May 15th. So it's been such a fun journey. I love being here. And it's even more fun now that I'm doing Twitch things with you, AM. So thanks for having me.
Hey, nobody has ever said
And
that
thanks,
their
Paul.
life has gotten more fun because of me. Wow. Okay, Kirk, who are you? Tell us about yourself.
Yeah, I'm a technical evangelist over at Datadog, and it was just 2 years over at Datadog for me. And so I've been more focused around kind of the APM side of product in the kind of stuff I've done publicly. That's
Very nice.
kind of it.
Wonderful. So, Claudine, number one, Paul is asking, where is Bacon Cam?
I know we gotta get that in place. But
We're gonna get Bacon Cam.
if you guys don't notice, there is a dog sleeping in a tiny little bed behind me. That is my dog named Bacon, and he is actually vegan. He does not eat animal protein. So AM, meet Bacon, your new homie. I know you guys met last week, but I forgot to point out that you're totally homies.
Yeah, you didn't tell me that Bacon was a vegan, and I mean, by law, I have to tell you that I'm vegan in the first 5 minutes. I think I just made it under 405. Oh, it turned to 405 right as I was saying it. It's wonderful. Kirk, you're also of the veggie persuasion too.
Vegetarian, not quite as extreme, but
okay. Well, yeah. I am definitely known for my extreme, right?
Very on brand. Very on brand.
Yeah. Anyways, so I have to ask one question first, but I should probably tell you all at home watching what this show is all about, what we're going to do today, who should watch, all those types of things. Today, we're, like we were saying, welcoming Kirk from Datadog. Kirk's going to give us a live demo of working with ECS. But before that, Claudine is going to take us through the basics of what is ECS. So, I'm super, super excited to learn more about ECS and what it can do. And then to see how you can monitor and get metrics out of it into, some dashboards and other things with Datadog. My question, though, and it's an important one. I always ask really important questions. It's kind of a hallmark of my personality. Kurt, do you think, well, actually, I should probably start with Claudine. Claudine, are you interested in licensing the likeness of Bacon to Datadog, like as a new mascot? Would that be?
I would totally consider it.
Okay. All right. So we've got that on the table, the considerations of the table. Now, Kirk, it's up to you to take it back to Datadog. Negotiate.
Okay. I will circulate it internally.
Okay.
We'll see what comes back.
Wonderful. Cool. So Claudine, you're going to kick us off with some ECS stuff, right?
Yes, I will. So I am going to do a high-level overview of Amazon Elastic Container Service, ECS. I'm also going to be touching on things like Amazon Elastic Container Registry, ECR, AWS Fargate, and Amazon CloudWatch as well, because monitoring your infrastructure and your applications actually turns out to be critically important for the success of your business, as I'm sure everyone here would agree. So first of all, though, I'm going to start off with just a few important concepts, just in case we have people joining us today who have very little to no exposure to containers. So first of all, what are containers? I think we can start there, right?
Yeah.
So there are so many different computing environments that exist, right? Your engineering team may have members who use Windows machines, while others have Macs. Some may have Linux machines, and we also have different Linux distributions. They may be using different versions of these OSs as well. And if you use virtual machines, those virtual machines could contain different guest OSs. Maybe someone on your team writes code or develops code using Python 3, and there's a QA engineer that tests using Python 2.7. So these variances in environments can cause a lot of operational inconsistencies because your applications are not going to behave the same exact way across different environments. You're not even going to be able to deploy them the same manner when you're dealing with different environments. So containers are meant to solve these inconsistency issues. So the main principle behind using a container is you just load your code and everything that your code needs to run. I'm talking about dependencies, libraries, config files into a container. And this container enables your app to run the same exact way, regardless of differences in your infrastructure. How's that for a container definition?
That's one of the hardest parts, right? Is dependency management, right? Anybody who has an extensive background in ops I guarantee you run into the issue where we had this version of the library in prod and this version of the library in dev and this version of the library in QA, and nothing worked, right? So I think that's a great summation. That's perfect. What do you think, Kirk?
Yeah, sounds good. I think one of the things that tends to happen a lot too, hopefully not as much with containers, is when somebody, maybe not you, maybe you, logs into production and starts changing things and things break and you wonder who broke it and where it was. And so ideally with containers, you kind of get that immutability where you deploy an image and that's the image, and then you never get around in there and start messing around with stuff. So I think that's another important piece, at least for me, as somebody who has never changed things in production and broken things.
Yeah, me either. Totally. Never done that.
All right. Well, good for you guys.
I definitely have, by the way.
Never. I've never. I don't even know how to access production, actually. Wait, is that better or worse? I can't tell. Also, Kirk, we had come in from chat. A great screen named Babe Cafe asks, could they put in a PR for changing the spelling to DAWG for Datadog.
Datadog.
Seems very relevant. I'm sure.
Yeah.
You
Okay. Cool. Put it on in.
I think they're also vegan. Babe Cafe.
Yeah, I saw that too. Yeah.
Yeah.
No meat stream. Claudine, you're not a vegan though, or a
I am
vegetarian.
not.
It's okay. It's okay.
I used to be. I was vegan for about 5 years in my past
Wow.
life,
Yeah.
and I've totally recovered from that. And now I'm a healthy omnivore.
Street cred.
Totally. Great. Okay, so should I continue with this thing that I'm supposed to be doing?
Absolutely. I know
Awesome.
you've got some stuff to show us too.
Yes.
Let me know when you need.
So there are different ways to create containers, but one way that has become very widely adopted is the use of a platform called Docker. And what does Docker do? So Docker really enables you to create, deploy, and manage containers more easily. It gives you a set of very simple, ready-to-use commands and automation tools. I'm actually going to show you guys a little demo, and you'll see some really basic Docker commands that I had to learn how to use for today's demo. But yeah, so you'll see, like, I'm going to have like a little Docker image that I'm going to be pushing into ECR, and I'm going to show you guys around this tiny little Docker file that I wrote for this demo as well. But so what if your architecture though contains many Docker containers that you have to run and manage, right? If you have maybe 5 of them, it probably wouldn't be that challenging to manage these 5 containers, but we're talking like, several hundred, even thousands of them. If you have like this huge microservices architecture that you're operating in production, you're probably going to want to look into a container orchestration service. And this is where ECS comes in. And what does ECS do?
Asking me or Kurt?
Whoever, yes.
I say AM.
Both of you can answer.
AM.
Okay, AM.
ECS schedules your containers to run in different types of ways. You can actually pick a few different ways to schedule them. I'd say the bread and butter way, right? The typical way is just as like a running process like you would on any type of regular operating system. But to Claudine's point, right? Containers aren't new. Like that's not a new technology. Containers been around for a long time. But what Docker has done is taken a bunch of these older technologies like containers and C groups and namespaces and these things that were disparate across the Linux environment and these kernel ideas, and made them a lot easier to package and use to isolate these running containers. And so, just like Claudine said, once you start spinning these things up, in the thousands or the tens of thousands, doing that manually is just not possible. So you need some sort of orchestrator or scheduler platform to manage how your workloads get deployed and how your containers continue to run. And ECS is one of those choices. EKS is another choice, or Kubernetes in the larger grand scheme of things is another one of these choices too. I guess Docker Swarm is still a thing too. You can probably still use that, I think. I haven't checked it in a long time, but yeah, these things come in and out of favor. But ECS is Amazon's scheduler, so it's specific to working in AWS. Is that a good? Did I do okay?
That was amazing. Kirk, do you have anything to add to that before I go into like fundamental ECS concepts?
I'll let it stay there.
What's that?
I'll let it stay there. I'll let it I'll let it in there.
Cool. Awesome. I may have to share my screen here, AM, if that's okay.
Yes. Yeah. I will switch over once I see it.
Oops. Actually, maybe I need to share my screen first and then. Sorry,
It's okay. It's okay. I'm waiting. That's us.
Okay. You see me?
Yeah, let me switch back over. Here, you want to pull up what you're going to
There you
show?
go.
There
we
we
are.
go.
Right.
Wonderful.
Awesome. Yeah. So I'm just going to go over like really fundamental ECS concepts. And then I'm going to do my tiny little demo that I prepared for today. So we've already talked a little bit about, Docker containers and Docker container images. Did I actually define what those are? Or do we need to actually go into that a little more? I don't think we defined it. But a Docker image is really just a template with instructions for how a Docker container gets created. And then I mentioned a little bit about a Docker file that I'm going to show you later. But a Docker file specifically contains those instructions for how to build a Docker image. And then there's the Elastic Container Registry, ECR. This is a fully managed Docker container registry that can host your Docker container images. It's integrated with ECS and the Docker CLI, so it's easy to push your Docker container images to it from your local machine so that you can use them in production deployments with ECS. Then we have the ECS cluster. What's an ECS cluster? It's really just a group of EC2 instances where you place and run your containers in. There's also this concept of an ECS container agent, which is required for every EC2 instance that's connected to your cluster. What it does is it's responsible for reporting to ECS the status of each instance, and it also tells ECS if there's a need to launch more containers. Then there's a task definition. And these terms admittedly are very confusing even for me. Like it took me a lot to actually wrap my head around these terms. So you guys feel free to chip in here if I'm not doing any of these terms any justice. But where am I? The task definition. Kirk, do you have anything to add?
I was just saying you're doing great. No worries.
Awesome. Great. So the task definition.
It's funny. It's like all these things you have to translate from Amazon speak into like, oh, that's what that is, right? Like ECR is the same thing as Docker Hub, right? But it's just the Amazon version that is closed off and private. It's not a public repo, right? It's a lot of these things, right? We put all this Amazon kind of flair on it.
Right. So the task definition, what is that? So the task definition essentially defines how a Docker container is supposed to be run in an instance. It contains things like the URI for the Docker image that you're using, CPU and memory usage for each task, what the launch type is that you're using. So with ECS, you can choose between two launch types. You can choose EC2 or you can choose Fargate, which I'm going to talk more about later. A task definition would also contain the IAM role that your tasks should be using so that they can talk to your other AWS resources. It also contains things like your networking mode. So basically everything that ECS needs to know about how to run your container would be in your task definition. A task is an instantiation of that task definition. So when you run a task, what really is happening is ECS is looking for EC2 instances in the cluster that meets the requirements that you've indicated in the task definition, and then it has those tasks executed in those instances. And then there's a service, and I think this was like particularly hard for me to understand in the beginning as well. But essentially, a service is what's responsible for managing your tasks and making sure that you have your desired number of tasks running simultaneously at any given time. So, for example, you have a desired task count of 2 and one of those 2 failed, the service will spin up a new one to replace the one that failed. It also distributes these tasks across your cluster according to what's called the placement strategy that you've indicated. So for example, you might want tasks spread across instances across multiple availability zones. So that's that. Those are those terms.
Fargate's my favorite of those terms.
What is your favorite?
Fargate.
Target.
No, Fargate.
Oh, Fargate. Yes.
Yeah.
Sorry.
Okay. Target. Yeah. I mean, I also love shopping at Target too.
I know. I'm like, I need some toilet paper for this afternoon, so I may go to Target. But what is Fargate? I'm actually going to go over this a little bit in my demo, but yeah. AM, why don't you tell us what Fargate is?
Fargate is, in my opinion, the easiest way to actually build with containers. A lot of people call it serverless containers, which I just feel like we're getting out of control when we do this, when we just plaster serverless on everything. But the idea is there, right? The idea is that you don't have to worry so much about scaling up or down infrastructure. You don't have to provision out EC2 instances for you to, have containers to run on, things like that. But at the end of the day, it's super easy to define out, get your container put into one of these declarative methodologies like your task definition, for example, in ECS. And then you tell it to run on Fargate, which means underneath the covers, all the infrastructure, the EC2 instances that your containers actually run on are provisioned for you, right? You still tell it things like, I need, subnets in this VPC, and I want you to deploy stuff into this, subnet in this VPC. But it goes and handles spinning up and down these EC2 instances.
Cool. Thanks,
I love
AM.
it. It's my favorite. You can use it with EKS now too, by the way.
Awesome.
Oh, wow. Today I learned.
Cool. So I have a demo that I prepared.
Oh, yeah.
Yeah. Great.
Okay.
I'm getting
Let me
hands on here.
switch back over to.
Yeah, show my screen.
There you go.
Yeah, so what I'm going to show you guys here is I'm going to show you how to push a Docker container image from my local machine to ECR. And then I'm going to use this image to deploy a very, very simple container application through ECS. I'm going the Fargate route, so I don't have to configure EC2 instances for my cluster. So during this demo, I'm also going to touch on Amazon CloudWatch, which is a monitoring and management service that gives you insight into your AWS resources and how you can benefit from using it with ECS. So can you see my screen? You're showing
Yes.
my screen, right? Okay, great.
Absolutely.
Awesome, great. So I have in my local machine an extremely simple Docker container image that contains, let me just clear this. Sorry, should have done that. It contains an Apache HTTPD and an HTML page that contains some text and a graphic. And let's look at my tiny little Docker file. So again, a Docker file contains a set of instructions for building your container. And this one is very, very short, very simple. So with Docker, you get access to these base images that have already been created and that are ready for you to use and build upon. So the first line in my Docker file is an instruction to pull the base image for an HTTPD container from Docker Hub, specifically the version that's tagged latest. And the second line is really just an instruction to add the entire current directory, which contains my index.html file and my images folder, to the local htdocs directory of the actual EC2 instance that is going to be running this container. Simple, right? So
Yes.
I want to push this to ECR. And so the first step here is I'm going to create a repository in ECR that I'm going to be pushing this to. So let's start there. I'm going to name this my, oops. So here's my sample HTTPD repo. Back to my console. So I'm going to run a command that actually packages everything I have in this directory. And I'm going to tag it because why do we tag things?
Find it later.
Yes.
That's my reason.
Give them real names.
Right, exactly. So I'm actually going to grab my repo URI here. And then I am going to push it to my repo.
All right.
We had a question come in over chat, about using local instead of pulling the image from like a Docker hub or something. And I think one, Claudine, you're just doing a demo, so
yeah.
And two, sometimes. And this probably wouldn't then be a local image, but it would be from some sort of repo that was locked down, or if you're working in a company that has certain images that they're allowed to use, you may have a locally sourced or distributed version of some sort of repo. ECR actually operates in that way too, to where it's not a public repository. You're not pulling like from everyone who's ever built a container and pushed to that repo. You're just pulling images that are accessible for whoever's working in your AWS account, essentially. You could use Docker Hub with ECS as well and pull images.
Yep.
So
in my demo, I'm going to be using Docker Hub images.
There you go.
Yes.
Different strokes for different folks, I think.
I also, sorry.
Yep. Right, Claudia.
I wanted to point out that for clarity, I was able to do, I was able to easily push my Docker container image from my local machine to ECR because I've actually installed what's called the ECR credential helper. I actually had a link to that. Yeah.
That sounds nice.
Oh, actually, I lost it. But yeah, I installed it in my machine so that I could get my Docker daemon to authenticate into ECR using my AWS credentials. So yeah, I think that's a very important point that should be mentioned here.
I'll find the helper and drop it in chat.
Yeah, I'm trying to find it as well.
I've got it.
Okay,
Yeah.
cool.
I think the GitHub link at least.
Thank you.
You got it.
Thanks, Sam. Okay, great. So I have my image here, and now I want to start the process of running a container app using this image I just pushed into ECR. I'm going to start creating what's called a task definition.
All right.
And I'm going to choose Fargate because I don't want to have to worry about provisioning and managing EC2 instances on my own. I'm going to name this my sample task definition. And I'm going to choose the ECS task execution role because why?
Because you want to execute the task, maybe?
Yep, exactly. And then I'm just going to choose the minimum memory and CPU options here. So I'm going to add the container that where is that one? Sorry, guys. I need my image URI for that image that I just uploaded into this repo. So this is my sample HTTPD container. And here's the image.
Okay, there's the URI. Gotcha. Okay.
Yep. And this is, I'm going to map it to port 80.
Sounds reasonable for an HTTP server?
Right, exactly. And I think I'm just going to leave the rest of these fields blank. Do we want to talk through some of these fields, though?
An hour later.
Okay.
You just do it later.
Okay,
Yeah.
cool. All right, so I'm just going to add that. And create. All right, so now I have a task definition. And now I can create a cluster. Again, I'm going to choose this option. I'm going to name this my HTTPD cluster. And I'm going to enable container insights. I'm going to talk about that more later, but I'm also going to create a new VPC for this cluster. And now we can just talk while my resources are getting provisioned.
Okay. I was going to give a shout out to ECSworkshop.com. So if anybody is doing this, starting with ECS for the first time and wanting to go through a really great tutorial, Britt Langston of the developer advocate team here at AWS built this. He also built the EKS workshop as well. This workshop really helps you learn the ins and outs. It's really hands-on. It's great. The other thing too that came up while you were working, Claudine, somebody was asking about that role, that ECS task definition role, and I was explaining in chat that you actually have to grant permission to ECS to be able to do certain things. Services in AWS, generally speaking, can't just assume the ability to alter other services in AWS until you give them permissions through IAM, and usually it's with an IAM role. So I didn't know if you wanted to talk more about that too, and that task definition role, but that was my quick explanation in chat.
Cool, thank you.
Got it. Got you back in the chat.
Thank you, Ray. I know you do. All right, great. So my cluster has been created. And so now it's time for me to create a service. And again, what is a service?
What is a service?
What is a service? So a service is responsible for managing your tasks. And again, tasks are instantiations of your task definition that you created. So, I want to make sure that, for instance, I have I have two tasks running simultaneously at any given point in time. So I can tell my service that. And what it's going to do is, if one of those tasks ever fail, it's going to actually spin up a new one to replace that. So let's create a service it's a service for this task definition that I created called my sample task definition. I'm just going to give it a name.
It's like layers and layers of abstraction, right? Like you start with the abstracted container and you go, how do I run that? And you get a task definition, right? And the task definition tells your task how to build the task. And then you're like, well, but should I just run a task? Well, no, because it'll probably die at some point, right? And you need it to spin back up. So that's your service, right?
Right.
There you go.
Okay, great. So, so again, I chose the Fargate launch type. I'm telling it that this is a cluster that I want for this. Two tasks, minimum healthy percent is 100 and maximum is 200. And I'm going to just leave it at rolling update.
Hey, Claudine.
Like that. Yeah?
We got a request. Will you zoom in a little bit? Command plus.
Where do you want me to zoom in?
Just like your browser, like make your browser a command
bigger?
Plus. Yeah.
Do you want me to? Plus. Okay. Do you want me to also? Do you want me to go back to the previous screen or?
Sure. I think somebody might have missed it. So.
Okay. All right. So yeah, I chose. Oops.
Uh-oh. Oh no.
Amazing.
Just when you need it.
Ooh, we're gonna see some creds. No.
Hopefully not. All right. So I was doing my sample. I was creating a service from my sample cluster.
So now we get to see it in full view now.
Yeah, right. So let me actually make this bigger. Does that look
Perfect.
good to you guys?
Yep. That looks
Yes.
great.
Okay, so again, this is a Fargate launch type. The task definition, I'm going to choose the one that I just created called my sample task definition. And I'm going to have these tasks running across my sample cluster. I'm just going to give it a name, my sample service. And by default, the service type here is replica. What does replica mean?
It's just creating multiples of the same thing. Replicating,
And-
right?
Yeah.
Yes.
You know what I would do?
Yes.
I would hover over that little eye.
Great suggestion. Yes. So replica services place and maintain a desired number of tasks across your cluster. Daemon services place and maintain one copy of your task on each container instance.
Okay, so this is actually a good time for me to interject here.
Yeah, go ahead.
Daemon service, right? That sounds a little bit weird. The daemon service is going to schedule a container to only run once per host. If you have something that you really only want it to run once per host, like, I don't know, maybe it's ingesting metrics or ingesting traces or monitoring the server itself, something along the lines of a Datadog agent, that's going to use that daemon instead. You want to make sure that you don't have more than one instance of Datadog, for example, the Datadog agent container running on your server. So continue.
Cool. Awesome. So I'm going to just do like 2 for this one. And I'm going to leave it at rolling update. And I'm going to choose next step. That's the VPC that I chose. I think so. But it's not letting me choose my subnets for some reason.
Are we sure we have the right VPC?
Oh, maybe I should use this one.
Okay.
Yeah, this was incorrect. I'm not sure why it shows that as or by default. But yeah, I'm just going to choose both the subnets that were spun up with that new VPC.
It was just helping you.
Right?
Here's some help with the wrong thing.
I'm not going to do a load balancer for this demo.
That's fair. I have
Yeah.
one. So
Awesome. And then I'm just going to choose next step. I'm saying do not adjust the service's desired count and create it. Ooh, my service already exists. Okay, well, this is messed up.
maybe you did a dry run before and it had the same name?
Yeah, I think it does. I think it. That's possible.
All right, there's that edit button. Oh, okay. You got it. You got it.
Should I? Okay, so should I just start from scratch and just breeze through it? Sorry.
It's okay.
You're pro now.
Stuff happens.
Yes. I can tell you it takes more than one time. Every time.
Right.
Wait.
Oh, I learned that this weekend, most definitely. All right, just breezing through it now. Okay. Hopefully this works this time.
Oh, I see the green.
It's green.
All right.
Now I can view a service.
Yes.
Look at that. It's glorious.
So now we
It's
gotta wait
nice
for
when
that time.
things are running.
Yes. Congrats.
Right, exactly. Okay, so this is my sample cluster. And so now it's active.
Okay.
And now I'm waiting for my tasks to actually start running.
Nice.
Yeah. So it might take a few minutes.
You got nothing but time. I guess.
I definitely do. I'm not. I'm here with you all. Like I'm just hanging out.
Yeah. All
Got
right.
some of my guitars in the background.
Yeah. What kind of guitars you got?
I've got a lot. I've got 4. It's a base over there.
I mean, 4, but what kind of 4?
Oh, I've got a guild. I've got a Fender Jazzmaster. I've got a Les Paul Gibson and a Fender bass.
Okay.
T-bass.
T-bass. Okay. Nice. What's your
All right,
favorite?
so it looks like I have a task that's running.
All right.
So hopefully this works. I'm not sure. I mean, I've made many, many mistakes before, but we'll see.
Let's see. Fingers crossed.
Yay! It does work. So
Oh!
see, this is an HTTP. This is my control. Yeah. So I that index HTML and that graphic that I copied into the htdocs directory of my HTTP web server is here, so you can see that. And what a fantastic logo! Thank you, Paul, for creating this.
Yeah.
Incredible. Beautiful demo. Great work.
I love it.
Thanks for hanging out, guys.
So, we just did a lot. Well, we didn't do anything. Claudine just did a lot. Let's give full props where they are deserved. But let's summarize and make sure anyone joining just now knows what they just tuned into, this crazy show. You want me to take a stab?
Yeah, go ahead.
Okay, we are. The chat is totally trolling me about how much I did in that segment, which is a lot. Anyway, we are Howdy Partner. We're joined here today by Kirk Kaiser from Datadog. We're going to learn all about Datadog, but before we learn about Datadog, we just learned about ECS and scheduling tasks, writing your task definition, turning that task into a service so it's not just one singular task running all by itself. And who told us all about that? Why, Claudine did. Claudine, a partner solution architect here at AWS. She's amazing. I'm also a co-host. I'm here. I'm just asking questions. That's my role. I'm A.M. Gravelny. And I believe now we are ready to kick it over to Kirk, right?
All right. Yes, let's do this.
Thank you, Claudine, by the way.
Yeah, totally.
Yeah,
Yeah, and I forgot
amazing
to mention that actually, there is such a thing as container insights that I actually enabled for this cluster.
Oh, do you want to show it? Do you want to take over?
I think you should talk about that and why you should be monitoring your ECS applications. Why is that important? Yeah.
Okay. So there's a few reasons that you can do it. If you want, you can do yours first because I have
I don't really have much. I just wanted to show them the Container Insights dashboard and how it makes everything, because before the time of Container Insights, you actually really needed to implement custom metrics on CloudWatch for you to actually monitor your ECS apps. So Container Insights abstracts all of that. It's currently in beta, but it makes things easier for you as far as monitoring your ECS clusters. So that's really all I had to say.
Okay.
Yeah, it's super cool. It lets you get insights at the container level instead of just at the EC2 level, and pipe it into CloudWatch.
Yeah.
That workshop, by the way, ECSworkshop.com, it'll walk you through setting up container insights as well, how to do that. Okay, so I think, Kirk, you got your screen ready to go, don't you?
I do. I'm ready to go.
Here you are. You're pro.
All right. So I believe the link was shared for this repo in the chat. It's this kind of shop I've started working on, and it's been taken over by a couple other people at Datadog. We've had at least one external contributor. And so the idea with Datadog is kind of setting up monitoring and being able to see what's happening in your software systems. And generally speaking, it's difficult enough when it's just one of you. When you start to work on a team and you have multiple people pushing code at the same time, it gets really confusing. And so Datadog is kind of a platform to help you kind of manage that chaos of multiple people working on a code base at the same time. So this is kind of a contrived example application that I use to kind of showcase what it's like in a real world-ish software application. So this is an e-commerce shop. If we look, I've already deployed it behind a load balancer to AWS using ECS on EC2. And you can see I put it behind the load balancer because straight out of AWS, I get that load balancer URL. I can click around, and it's really slow, first of all. You can see at the top left corner, this took 4 seconds to load. It has a broken-ish shop, and if I click on some things, I'm going to get errors, right? And so the idea here is that we have a broken application, and we want to see where the application is broken and who it is. So the contrived example that we have is that we're this online shop and we're moving towards microservices. We had this monolith. We've been on Ruby on Rails, and we've learned that we really want to go to microservices so that we can have teams work independently and not have everything break. And so let's kind of look at this. If you scroll down through the repo, you'll see the application. And you saw there's this error here, and we can see line 14 seems like there's error here. One of the things that starts to happen when you split up work into teams is that, without proper observability of what's happening within the application, teams can default to blaming each other for being the one who broke it last, right? You can kind of be like, well, I haven't changed anything on my end, so because I didn't push any changes, it couldn't have broken because of me. And so that's something that as you scale to more and more people working on the same code base, that's something you want to be extra cognizant of. So in this hypothetical scenario, there's a few different things here. And if we look at the folders, we have storefront end broken instrumented, storefront end broken no instrumentation, and then instrumented and fixed. So you've got those 3 different steps. So if you want to learn how to instrument Datadog, you start with this no instrumentation. It actually has a Docker file right in here that we use to build the entire thing. And so all of the pieces to build each of these images are put in one spot. And so if you wanted to learn, hey, how do I instrument an application using Datadog on Ruby on Rails, you can just jump right in and find it here. When I'm developing in containers especially, I really want to manage how quickly I can turn around things, right? Like if I'm working on code, I want to see it break sooner rather than later. I want to know if the changes that I'm making are ruining my container entirely, or if the code is going to work when I deploy it. And so one of my favorite tools for that when developing locally is Docker Compose. So we talked before about scheduling containers using ECS, and ECS being a container scheduler. With Docker Compose, let's actually look into one of these files, Docker Compose files. So within the Docker Compose files, we have a few different versions. We have no instrumentation, instrumented, instrumented and fixed. Let's look at broken instrumented and take a look about how we can use Docker Compose. So Claudine showed using a single container, right? And that single container was just exposed to the outside internet on port 80. Docker Compose lets us create services, just like we saw in ECS, right? And these services are just containers that can speak to one another. And so the very first one we have is this Datadog agent image. So the Datadog agent image is a container, just like any other container. But the things that make Datadog work as a container and pick up on the underlying host, things like CPU, memory usage, containers running, is these volumes here. So this is going to actually mount the host computer's Docker socket into the Datadog agent container. And then we're going to get the same thing for the proc file system. So I can read things like CPU usage, memory usage. And then cgroup, I am totally spacing on right now, but maybe somebody can say it for the chat. Labels we use to label our logs. Let's actually jump right into Datadog. It's a little bit weird to talk about this and not see it. So we went to that e-commerce shop, and now you can see all of the containers that are running onto that instance that are deployed to, right? So we have a discounts service here, or discounts container, a database container, an advertisements container, that legacy front end that I said before, and then the Datadog agent itself. And so if we go, let's go over to Livetail. This is one of my favorite features. So if I go to the site, sorry if this I don't know how well screen switching works. go to the site, a reload. Let's click into an image. We can see all the logs coming in real time in LiveTail. So if I wanted to just see my e-commerce spree, let's see, what is it? It is a service. E-commerce spree observability. I just want to see the things coming from that Rails front end. I just filtered down to the logs only coming in from that front end application.
I really just want to see the cool hats, personally. I mean, that's what I've been seeing, the cool hats banner for minutes now, and it's taking everything inside me not to just blurt that out.
You can spin up the application yourself. There's also the load balancer. So let's go over here. And yeah, if we go over to the hats, we'll see if we get the ad. So that's part of the advertisement service.
Oh, okay.
Yeah. So this is an advertisement. It gets pulled in from the advertisements API, and this is a discount code over here. So this discount code gets pulled in from the discount code API. So I know we're bouncing around a bit, but one of the things that we do here is we set environment variables. So because a container is kind of a immutable thing, right? We're not supposed to be changing any things. One of the ways that you can set configuration values within containers is through things called environment variables. And so here we've said that we're going to use a DD API key. That is the API key you get out of Datadog. Now, if you have it set on the external shell, the one that's running on the host, it'll be set within the container. And then we do a bunch of other configuration here. We set an environment. So here it's Ruby shot. If we go back over to Datadog, let me close this, and we go to services, you'll see that we can have this environment Ruby shop. So if you had different applications, different environments, dev, prod, etc., you can isolate those using that env setting in general. So the other big thing to call out here is this label. And this is what sets the type of ingestion for all of those logs coming in to Datadog. So we talked before about Docker Compose and how it's really nice. Let's actually go into the terminal and bring this up locally. So Docker Compose, and I've already set the environment. Let's go into the actual.
That is super small, Kurt. Can you?
It's too small? Do I need to go bigger?
Yes, please.
Okay, hopefully you can see it now.
Maybe a couple more.
More?
There we go.
Okay.
That's pretty good. Thank you.
I have Docker Compose up. -F, Docker Compose, instrumented. Let's do that one. Oh, you're not going to autocomplete for me?
That'd be too easy.
Yeah. Maybe not. I'm doing the wrong commands. Let's see. Maybe it's the wrong order. Yeah, that's it. So it's going to pull all of those containers and link them all together for me. And then another big thing is it's going to mount these volumes, or not in this Docker Compose actually, but normally if I were developing, right, I would have a volume mounted where I could have live reloading of the code in my current directory. And so this actual version of the Docker Compose doesn't have that because it was used for another workshop. So let's just kill it. Let's just kill it. We'll skip that. Yeah, let's keep going. So if I go back over, we're seeing some errors coming in, right, on some of the pages, but not really all of them. So the application kind of looks like it works, kind of looks like it doesn't. One good way to check out what is working versus what isn't is to come over here and look at a high level all of the services you have running in Datadog. So if we look at the error rate for everything, it doesn't seem to be the advertisement service or the discount service, right? Because if we look at the error rate for both of them, they're at 0%. And for Datadog, for the front end itself, there's a 0.88%. So we click into that, we're going to see actually all of the errors that we had. And so we can click in and find what pages are generating those errors. So rather than blaming the new team who just spun up a new microservice or who maybe just deployed, we can go in and see which pages in particular. And so it seems like the show controller is what's generating this error. So if I scroll down, we can find one of the traces that actually generated this error. Along with it, we can see the logs for the incoming request, along with the error. And it says undefined method for nil class. And so we can actually see the line number that's generating the error and the fact that it isn't one of those downstream services in general. So much quicker way to kind of diagnose errors. If we also wanted to, we have the same sort of live tail for traces. Let's actually look at a trace. Let's refresh and see what a trace looks like in general. Okay, so we have a few traces. So clicking into a trace, yeah. And so, by the way, this is Livetail. This is a newer feature for Datadog. You can see I've set that I just want to see the environment for RubyShot, and then we can see the actual request that I just made. So the initial request comes into the store front end service, and over here you can actually see what percentage of execution time was spent in each one of those microservices. So in this case, it came into the store front end, right? And it spent 18.7% for execution in the Rails. So we can see there's an HTTP GET request to a downstream microservice, the discount service that happens before the advertisement service. And so kind of in this flame graph, we can see the entire request across all of the downstream systems. So one more thing that kind of gets a little bit confusing is knowing what is going on with your architecture and how requests are propagating across your internal systems, especially if you have teams creating new code, doing new deployments. And so for that, we have this service map. And so we can see inside of a service map and see all of the services and the dependencies as they come in across your entire store. So in this case, we can see the store front end hits a SQLite database, actually. It's not on a production-ish Postgres database or anything along those lines. It also hits a cache, which I believe is just a file system cache. And then the two other downstream dependencies are the discount service and the advertisement service. So let's see what we can get out of that.
Cool. Let me pause you right there just for a second. Couple things we should probably do a quick recap, but also, how's Bacon?
How is Bacon?
Bacon Watch 2020.
He's doing what he does best.
Sleeping.
Yep.
Claudine, do you want to tell everybody who we are and why we're here?
Yeah.
I mean, like philosophically, not the show. I mean, like all of us.
I'm still trying to figure out why I'm here.
How about just the show? Just the show then.
If you're just joining us right now, we are Howdy Partner. My name's Claudine Morales. I'm your host. I'm a partner solutions architect based out of Seattle, Washington. I'm joined today by one of my colleagues, A.M. Grabelny, based out of Austin. And, of course, our friend Kirk from Datadog. Today we are talking all containers, ECS. Yes. And Kirk here is showing us how to monitor your ECS applications using Datadog.
It's actually a really good segue. Let's look at ECS. We haven't looked at ECS. We've been talking about containers, volumes, etc. But before I do, one more thing. We can see that both the discount service and advertisement service are both using the same Postgres database. So if you're looking at like a potential weak link in your architecture, you can see that one might be the fact that if this database goes down or becomes unavailable, you're going to lose both the discount service and the advertisement service. So you might want to think about splitting that off into separate databases. So yeah, let's go look and see how ECS works. So this is my task definition for my e-commerce shop. And we mentioned before about never getting it right the first time. There might be a hint for how many tries. So yeah, the first thing I do is I have my first e-commerce shop, that same task definition we saw before. We set a networking mode. In my case, I set it to default. And I'm also actually on EC2. So instead of Fargate, I used EC2, and I deployed to an EC2 instance. I set a minimum amount of memory because I have a few containers, as you'll see. And if we look, I have more than one container defined, and I have all of those containers that we saw in the Docker Compose defined and linked together. So let's click into one of these and see what kind of things we can see here. Yeah, okay. I mean, that's no big deal. So we have default username and password here. This isn't exposed at all, just FYI for everybody. A couple more configurations we have. We have DD agent host. I manually set that to be the host name. We have analytics enabled, APM enabled, and we set that environment that we talked about before. DD logs injection.
Yes. Sorry, real quick. We had a question from chat from Ken. Any reason to use EC2 instead of Fargate with Datadog? Any difference?
So I believe there might be a difference in how you deploy the agent, right? So I mentioned before that the Datadog agent runs as a container, right? That gets those underlying volumes in general. Right. We set those. Let's look at those volume points.
But there's no
volume consideration. Exactly. So there's no volumes to mount to, right? So you need a different approach in general. And so there's different settings for Fargate, but there are docs on the Datadog website. Let's actually go to the Datadog website.
Cool. So, but no compelling reason to use EC2 over Fargate when you're also using Datadog.
No, not really. So one of kind of as a developer, my kind of personal approach is to keep things as simple as possible. And so for me personally, simple as possible means having an underlying instance. If I have an emergency, I can SSH into it and try to debug or fix something with a terrible hack in general, if that makes sense. And so speaking of which, there's two different actually ways to integrate. There's using the agent and ingesting CloudWatch. So you can actually set up CloudWatch metrics to get shipped to Datadog, and Datadog can pick up all of those things. We have a role, and we actually ingest a lot of services. If you look here, you'll see quite a few of the services that Datadog ingests out of Amazon Web Services. So this is kind of my favorite integration to set up in general, just because you end up getting so much information out of AWS over this. And you just put in your IAM role, it says it right here. You get an account ID, you add it, and then once it gets these permissions, you start pulling, and it actually pulls the AWS API and starts pulling in the list of everything. So you immediately see all of your infrastructure. It's like one of the most immediate payoffs in general of all of the Datadog integrations. It's something I really appreciate in general. That answer the question? I realized it was a little bit over.
I think so. We had another one come in. Transport for London asks, could you just run the agent as a separate ECS service and just point your other services and tasks at that service?
Yeah, so that is kind of what we do. I didn't show it because that would expose my API key. But we do have, let's see how close to showing it we can get. If I go to clusters and I click e-commerce shop, you'll see that I have a service for the Datadog agent. And so that's going to schedule it to be running in general. And it's actually running, as we said before, as a daemon service type. And so that's going to run once per server, right? And just pick up those metrics on that single server. So if we go over here, infrastructure, host map, we'll see there's actually a few of my servers. And then this is the server that we've got running all of our containers. And so you'll see a few things here. We can see we're running a Linux machine. Looks like it's got 4 gigs of memory. We can see all the tags that get pulled in from AWS. We can see the CloudFormation stack name, a bunch of other stuff. We can see that we have that environment tag that we set, Ruby shop. We can actually also add things here too. We can go back over, see our containers. We saw this previously, but we can see all of the containers we have running. We mentioned before that ECS agent. That's the thing that schedules everything. We can actually look in and see the command that's running on that container that is the ECS scheduler, how much memory it's using, what the CPU usage is, etc. for that specific container. You'll see ECS also uses an agent. We can see CPU usage over time by that agent on ECS. So just mounting that volume really gives you a lot of access to information on that underlying host. I hope that's pretty clear. Let's jump back into the application in general. So we have StoreDog, and if we go back into this repo, there's a few things that I want to call out, especially since we kind of have a limited amount of time. So we have on the repo itself. You want to see the cool hats? You want to see the cool hats?
I was just putting that out there into the universe.
Yeah, I think the problem with the cool hats is that we're going to get a crash.
Oh,
no, we're not. It works. Cool
but
hat.
it's a T-shirt. Wait a minute.
Yeah, the application is broken. Did I mention that? It's really actually difficult to build a purposefully broken application. It's really easy to do it not on purpose, but building one on purpose is a challenge. So yeah, let's go back over. So we could run this in Docker Compose, and it'll spin these all up, make sure the network's all linked together. We also have this follow along link right here in the scenario, and it should open up. Oh no! Oh, it's not public. Oh, never mind. Let's see. This is the real one. So unfortunately, our catacode scenarios aren't public, but you can go to my version of it, which is here. And maybe AM, you can post that in the chat.
Got it.
Yeah. And so that's going to give you a live area to do the entire workshop. And so you can bring up Postgres with that username and password. You'll see. And within here, you'll actually get a working environment and a working URL right out of here. We use Katacoda to run our in-person and virtual events. And so you kind of get this terminal, and you get the repo itself, and you can start playing around with and get something up and running really quickly. So definitely something to check out. Cool. And yeah, it's the same story. You have that Docker Compose up. Another thing that we have here is this Go Replay. So Go Replay is a really cool tool It's a tool that allows you to record traffic and replay traffic. So one of the things that's nice to have, right, is tests written for the software you're working on in general. But in a lot of cases, you just don't have tests. Things have been around for a while. People have had other priorities when it comes to writing tests. Go Replay allows you to record yourself browsing your site locally and then replay that local browsing anywhere else. And so if you don't have any tests, a good beginning point, starting point, is to use something like Go Replay to either record production traffic, right? You can record production traffic and then replay it later as part of a test suite. And then as you're replaying it, you can see if it generates those errors within Datadog. A super hacky approach, but it's especially nice in this workshop because it will allow you to see errors without having to click around in a slow site in general. How's everybody doing?
We had No questions yet. Just
Okay.
Kin commenting about logging and Datadog and ECS.
Okay. Cool. Any confusion anywhere? Anywhere you guys want me to drill in purposefully? Anything?
I'll let you know if they come back.
Okay. Okay, so this is another thing in the repo that I shared earlier, finding a bottleneck. So if we go back over to Datadog and we look at our services, we mentioned before we have like the front end service, and you can see the latency is pretty high here. It's 6 seconds. And if we look at the advertisement service and the discount service, they're both running pretty high latency too, right? So let's actually start with the front end. And let's see if we can get this latency down, or hypothetically get this latency down. So it seems like the home page can be around 10 seconds to load, which seems a little ridiculous for an e-commerce shop to be taking eight seconds to load a page, right? And we all know that supposedly purchases go up when your site is fast. So let's click into one of these traces to see the latency breakdown. And you'll see a significant portion of it is in this /discount request. And so that would be one of the places to look for what might be slowing us down in general. And we can actually see the URL that was called here, right? That /discount. We click in here, we can see via the tags from that trace what endpoint was hit. And I think, oh, it's not gonna show it. So that's actually another thing. So within our network, right, within our container network, there isn't sort of the same networking as we would have externally. Each one of those containers has its own network-ish stack. And so localhost for that container is only going to be localhost for that specific container. It's not going to be linked up to any of the other ones. And the way that you link networks in Docker, or Docker Compose at least, there's multiple ways to link networks in Docker generally. But within Docker Compose is you have this links variable. Let's actually look at it. And I believe the front end, which let me see if I can find it. There should be a depends on. Yes, here it is. And so we see in the depends on, there's a depends on agent, depends on DB, discounts, and advertisements. So these all each get their own, basically like DNS, right? They all each get their own name on the network, and that's how you resolve to it. So if I want to hit the discount service, that's actually the HTTP address I'll use. And so we see that here, that I'm hitting the discount service within those containers that are scheduled on ECS, and I'm hitting port 5001, and I'm hitting the /discount URL. So we can actually go look back over in our code and say, okay, is there something in particular in that discount service? Let's see. And that /discount method that might be taking extra time, right? So we have a clue to where there might be a bottleneck within our system. And so if we do look in here, we can see there's this time.sleep, which is the oldest trick in the book. Telling somebody you're going to speed up your systems, making them slow on purpose, and then deleting the time.sleep and improving latency wildly. You're getting that big promotion.
That's actually the quiddity of what makes me a programmer. Like my quiddity as a programmer is adding in time.sleep.
Yes.
Go on. Sorry, Claudine.
No,
Yes.
we have a question in the chat from Malgore.
Okay.
Would something like ASP.NET applications on iOS and Windows be automatically detected and monitored, or do you need to manually configure each app?
Okay, so there's a few different things, and there's a few different facets of what we mean by monitoring. So right now we've seen a bunch of stuff, right? We have this flame graph, and this flame graph works because of distributed tracing. So Datadog has a distributed tracing. It's called APM library for .NET, and so you would need to install that library into your software application, and then also deploy the Datadog agent. And so Datadog kind of takes a different approach in having an agent that you ship your traces to, and then those traces then get shipped to Datadog. So rather than going from your application direct to Datadog, we actually have you ship it to the agent. The agent collects, starts creating metrics. It actually strips stuff like, you know, in a trace you can see, let's see if we have a database request in here. There should be one right here maybe. You can see that we have potentially sensitive information within our database, right? And so the agent will actually strip those out and not ship them over to Datadog. So your sensitive information on your database would never ship to Datadog. So we have, you install the .NET library, instrument your code, you do things like setting those environment variables to set a name for it, and then those traces get shipped to the Datadog agent. Datadog agent filters out all of the potentially sensitive information you don't want to touch our servers ever, and then it ships that off to Datadog. It also collects statistics on all of the requests. Does that answer the question, hopefully? So not necessarily automatic, right? You have to install that agent. And then beyond that agent, if you want to get things like this flame graph of your request across multiple systems, then you also need to instrument with APM. And APM is actually different for each individual programming language. So if you go to Datadog's APM page, docs, there should be APM and distributed tracing. So there's this beautiful video, which is great. I would love to do it, but you can see all the languages that we have instrumentation for. And so you really just install the library and then set those configuration values, right, to what you're going to be using. Hopefully that answers it. And then it automatically gets instrumented.
So Malgore said that you mostly addressed the question. Malgore, if there's any clarification you need Kirk to make on anything, please let us know. Kirk, Transport for London wants to know if it wasn't an external service that was resulting in poor performance, how do you know, can you see more detail about where in the application itself the bottleneck or slowdown is?
Yeah, let's actually look. So here you see this http.request_get, right? We are all bottlenecks. So in this HTTP request get, there's a few things we can do. Like if we knew that we were calling an external API here, right, or calling an external page, we wouldn't necessarily be able to propagate our trace through their systems, right? We don't have access to their systems in order to instrument them. And so instead, we can label this, and rather than this being labeled HTTP request get, we can label it get whatever the name of the API is that you're calling. And then that way you'll know that that external API you're calling that you don't have control over is what is taking this amount of time. As for strategies, you can use that and get away with that because let's say it is an external API. There's no way for you to push code to that external API that you don't own and improve performance, right? But you can give the vendor, whoever it is, data and say, hey, look, you're the main bottleneck in our systems right now. Hopefully that answers questions.
Money probably helps there too.
Bribery in general?
Yeah, if you can give that vendor a lot of money, okay. Probably. Just kidding.
Yeah, and I think somebody was curious about how much instrumentation you need to do. So there is automatic instrumentation, right? It depends on what libraries you have. So as an example, somebody asked about .NET. You have a few automatically instrumented integrations. Let's see what they are. So here you can see I'm running .NET, but what framework or library you're running. And these are the ones that if you install the agent, install the .NET trace library, these are the ones that will automatically get picked up. It's actually a good segue. Let's look at the code for the instrumentation. So if you look in this Python example, there's no import of the Datadog tracer at all, right? There's no import of any custom code that we would use to instrument it. And really, there's nothing within the Docker file either that says really anything about Datadog other than in the requirements directory. We have ddtrace, which is the Datadog tracing library. But other than that, there's like no call, no import of the Datadog trace library in any of the directories, right? And so the way that it works in Python is one of my favorite ways of it working. In our Docker Compose file, this has no instrumentation. Here we go. In our Docker Compose file, we have this automatic instrumentation called ddtrace run. And so ddtrace run wraps around our Flask application, wraps around whatever Python application we have that's supported by Datadog, and automatically instruments all of it. So with this ddtrace run in front of our Flask run, and these environment variables set, that's all we need to do to get it completely instrumented with logging and tracing and everything else. Really my favorite integration, tracing library integration. Is there another question around traceability in general?
No, Kirk, I think so Transport for London was actually asking about what if it's an internal service, right? Not one that you're calling out to. What exists for
spotting bottlenecks?
Yeah.
Okay.
For your own services, right? So like the advertisement service, for example, in this.
Yes. So we can actually go over here into the spam. We can go in the spam list too. We can close it all down. And we can actually see, if I close all this, we can actually see execution time by our services. And so we can say, is Postgres our bottleneck? Should we be upgrading our database right now? And you look at this specific request for the home, for hitting the home page, and you'll say, no, I don't think we're going to get anything out of upgrading Postgres to a bigger, beefier server. It seems like the biggest one we can get here is speeding up the advertisement service, and the biggest one we can get here is speeding up the discount service. And so after we hit those two, we can start going further and see what might be taking up a bunch of time internally and start optimizing there. Hopefully that's closer to the answering the question.
Cool.
Okay, we good?
Yeah, good stuff.
Awesome. So we mentioned instrumenting the application, automatic instrumentation, right? If you have one of these supported libraries, it automatically gets picked up just with that configuration of the environment variables. We mentioned ECS, mentioned the task deployment. Fargate, somebody had mentioned Fargate before and about how you integrate with it. There's documentation here, and it's the same thing, right? It's that ECS Fargate task. And then we register it. We've got to change the policy. I think that might be different from the EC2. Don't quote me on that. And then the rest of it is really right here and setting the rest of the metrics. And I mentioned before how there's the Datadog agent container and then also that crawler that ingests CloudWatch metrics. It's the same sort of thing that gets picked up here. So I think that's about what I've got. If we don't have any more questions, there's also an online learning platform where you can run through some of these scenarios. We have the Datadog Learning Center, and you can take any one of these courses, learn more about using SLOs, which is a new product we just launched, how to best tag your application, working with observability in general, right? Monitoring, whole bunch more stuff to just kind of play around with, learn. It uses that Catacoder environment we saw earlier and gives you a whole bunch of stuff where you can start interacting. It'll spin up a custom Datadog environment separate from the rest of your company's environment, so you know, oh, I'm not breaking anything for anybody else in general. And so as somebody who is a breaker, that is a very reassuring thing to do. To know that you have a separate organization entirely, completely firewalled from the rest of the stuff you do. So I definitely recommend going through here, checking out the scenarios. My team, the team of people who I work with, have put a lot of time and energy into this. I'm really proud of what they've done. Yeah.
We did have another question from Malgor. kind of name is that? That's a crazy. I love that name. What about client side? Can you integrate with client side to get the full end-to-end?
A lot of ads for this topic. Yes, Datadog launched real user monitoring. And so that is going to let you see, what it looks like from your client side of things. And so with real user monitoring, you're going to get a piece of JavaScript and a key, and you're going to add that to your site, and it's going to give you basically very similar to the traces that we saw here, right? If we look at the flame graph, you get something very similar to this. If you've ever used Google developer tools within the browser, something very similar to that. The same sort of flame graph letting you know where the slowest part of your systems are at a high level visually. So real user monitoring is something that was shipped recently-ish. I no longer have perception of time, but yes, recent-ish from Datadog. So real user monitoring. Here it is. It's great. I had somebody demo it for me earlier this week. I was very impressed.
Is the acronym there RUM?
Yes, RUM. Yes.
Okay. That's what I thought it said. Somebody did that on purpose, right?
There are so many acronyms in general in our reality and in our world in general that it's tough to keep track of. Yes, real user monitoring. I prefer to not use acronyms lately.
Yeah, I think somebody worked backwards from that acronym though.
Yes, 100%.
Claudine, what do you think? What do you think about all this?
I think it was, so for me, here's what I'm going to ask Kirk to do, because he went over a lot of things, right?
Yeah.
And for somebody who's just getting started on this whole thing, they might be thinking, this is complicated. It's a bunch of flim flam. And I was actually challenged to say that word on air. So can you give us a very quick summary of what you actually just did there? Okay.
So there's a few things, right? So we deployed our task and our service. This was already deployed pre-stream, right? So we deployed our ECS service on EC2. I put it behind a load balancer. One of the lessons learned in production is always put it behind a load balancer. So I personally worked on I'm not going to say a startup-ish thing, where I came on as a developer midway through, the other developer left, and it was just an EC2 instance, and I pointed my DNS records directly to that EC2 instance. And 2 days into deploying it and having a lot of traffic, the site suddenly disappeared. And I started getting a lot of text messages, wondering what the hell I'd done. And it turns out that in the past, I think this is no longer the case, EC2 instances can just change their IP. No warning, no heads up, just change an IP. And so since then, I've learned to always deploy things behind a load balancer. Worst case, if you break something, you can point to another site real quickly. Gives you more breathing room if things go terribly wrong. So I deployed behind a load balancer. That's one, that mega side note. Put our tasks in there, and we used a very similar thing to our Docker Compose, right? This set of, here's my agent. I want to enable all these things, set my environment as Ruby shop. I want to use my discount service. I want to set my username and password. I want to set all these things. This is how I run my application. This is the command that runs once my application spins up. dd trace run flask run, which is a mouthful, but it just basically says flask run this application, but hey, let's instrument it with Datadog Tracer. And so we deployed this Docker Compose as an ECS task. And so using that ECS task and using the Datadog agent, we were able to pick up all of the underlying metrics on that EC2 instance. And so the Datadog agent ingests all of those, ingests all the traces, and then from that we can see the logs, traces, all that other good stuff on. Let's hit the site one more time. Let's go over, do logs, live tail, see the logs coming in as people hit the website itself. We can sort by whatever pattern we want. We want to just see the agent. I think it's the agent service. I don't remember what I named it. Let's see what we got.
I think, too, while you're doing this, Kirk, I think something to highlight is that, instrumenting your application here doesn't force you to actually make any changes to your code or add any libraries to your deployed code. Instead, you're doing it in the environment in which you are launching the application. So it lets that remain untouched, so to speak, for your instrumentation tools, your observability tools. They're not baked into your application, which I think is pretty desirable, right?
Yep.
Cool.
Yep. You got anything else?
We've got Ugg Squish talking about some evolution of Python logging, SnakeViz to Sentry to Datadog, and is giving some thumbs up for Datadog from a friend's recommendation and review.
Awesome. Definitely. We also have a public Slack. It's chat.datadoghq.com. Feel free to ping me if you run into any issues. And I am happy to help out and improve things. If you see anything that is confusing at all, I can help get the docs updated. The docs themselves are open source. The agent itself, the thing that runs on all of your machines, is also open source. Happy to chat about anything. Yep, you got it. Chat.datadoghq.com.
Cool.
Yep.
All right, so
Yes.
a couple things. Any parting thoughts for us, Kirk? I think you wrapped it up pretty well just then.
No, I mean, I think that, one of the things that we're seeing as an industry, right, is software development is growing up, right? It's maturing, and it means that there's more people pushing code quicker than ever before. Our systems are being scaled quicker than before. And so I think that, we kind of alluded to this a bit, but we didn't really expand upon it too much. But when you have multiple teams who want to deploy services that depend on other services, right, you kind of need one way to be able to see what is going on. And so that one way of trying to see what's going on in your systems is kind of what Datadog does. It gives you a single place to see across 100 people, 200 people developing on the same code base, what is actually going on? Where are things breaking? Are things breaking? And it kind of gives you the tool to make the unmanageable complexity approachable. And so that's kind of where Datadog as a company is going, kind of where this industry is going.
Cool. Claudine, what about you? What thoughts do you have as we wrap up?
So for me, I hadn't touched ECS in a very long time. I started learning it years ago, and I relearned it again this past weekend. And it's one of those other things that really take time to wrap your head around. So I'm just going to say that because I had a lot of challenges.
There are a lot of abstractions, yes, and that's kind of where Datadog can help. Is helping you wrap your head around, okay, I'm not seeing anything happening, and I don't know why nothing is happening, and I don't know why I'm getting these errors. Kind of having that live tail in your logs, right? It's being able to see in real time, what are the logs coming out of my containers? What is actually going on in there? Can be super useful in general. And it's something that I wish I would have had when I was pushing to production systems in general.
Also, before we go, how's Bacon? What's Bacon up to?
It's Bacon.
He's still doing the best thing that he does.
That dog, I've never seen a dog sleep that much. A dog is part cat, actually, I think.
Yeah, he just likes to sleep. He just likes to hang out here with me while I work, and he just stays in his bed.
Nice.
Sounds like the life, actually.
Yeah.
It's great.
I'm jealous.
Yeah, just hanging out in bed all day. That's cool. So I think that leaves us with our parting words, which you get to pick, Kirk. Remember, we had 3 choices. We got to review those 3 choices again. I got to actually.
No, I already know my choice. 100%.
Oh, the choices were yeehaw.
Yes. I know the other one because I know it's what I'm going to say.
Giddy
y'all
up.
come, giddy up. That's it. Thank you, Claudine. And y'all come back now. You hear? So, Kirk, what are you going to take us out on?
Giddy up.
Giddy up on over to Datadog's site and check it out.
Yeah. There we go.
You signed up for a free trial.
Yes, 100%.
Let's give an extra special thanks to Kirk for joining us and showing us and teaching us all about Datadog and AWS, and for Claudine, of course.
Yes.
Coming on and teaching us about ECS, but most importantly, we have to thank Bacon for just showing up.
Of course.
Just being here. And we are going to work on getting that Bacon cam set up. I think that's really important. So just keep tuning in. Every Monday, every Wednesday, throughout the month of May and into the month of June, we will be doing this show, Howdy Partner, where we talk with AWS APN partners. Actually, Wednesday we don't have a show, unfortunately. So you will miss us on Wednesday, but there's an AWS online summit, I believe, instead. So we've been preempted. I would say the online summit is probably more important than us. Don't you think, Claudine?
I would agree with that.
No. Kirk says no.
Well, we'll just talk to. Who do I need to talk to? You guys are more important.
We're growing in power and strength. I love it. So next Monday is when you can catch us next. We'll have a new APN partner on with a different host. Claudine, you won't be back until later on, but you will be back. Yes?
Maybe.
Man.
Bacon will be back.
Okay.
You did great. I loved your demo. You did it live. You had a setback.
I messed
and you
up.
recovered. No, you didn't mess up. Originally you had it, but it was just too small. So you didn't. It's not a mess up.
Somebody actually told me that I should have messed up more because it makes for a greater demo. So noted. For next time, I will remember that.
So the next episode is Monday, May 18th, featuring our partner, Weaveworks. And then we also have one Wednesday, May 20th, featuring our friends at Gremlin. So tune in.
Gremlin.
Chaos Engineering coming at you.
Who's the Gremlin with?
Eugene Wu and Anna Medina.